Hey, welcome back. Alright, so today I want to take you through the Midnight Starter template. We're gonna follow the README, top to bottom. And by the end of this video, you will have this thing running on your machine with a wallet connected and a contract deployed. We will start with the requirements, what the README asks you to install. Then we will go into the build system, which honestly the README doesn't really cover, but you kind of need to understand it. We will talk about the environment's configurations, how the .env file work, how the network configs work, and then we will actually run the template on all 4 networks. And at the end, I will show you how to connect it with both browser wallets, Lace and 1AM, because the template supports both, and people always ask. Okay, let's get into it. Okay, so these are the requirements you need to install before anything else works. Basically, there are 6 things. First, Node. You need at least version 23 or newer, with npm 11 or newer. This runs everything. So if you are on an older node, do yourself a favor and update before you start. Then we need Docker. Any recent version is fine. We need it for the local blockchain stack. 3 containers, we will see them in a minute. Git LFS. This one's important. It stores the binary prover and verifier keys. If you skip it, the files end up as little text pointers instead of real binaries. And then you get these really confusing mismatch verifier keys errors. So install it. Run git lfs install once and you are good. Compact. It's the Midnight contract language compiler. You will use it to compile .compact source files into TypeScript types and zero-knowledge proof keys. A browser wallet, Lace or 1AM. You need at least one of them for the front end. We will cover both later. And faucet access for the testnets, preview and preprod. Only if you are going to use those networks. If you are staying local, you don't need it. So you install git lfs through your system package manager. Then you need to run git lfs install once to wire up the hooks. Compact is a curl installer. I will let you copy that from the README file. The important part is pinning to .30 at the end. That matches what this template expects. Then you just verify everything. Node version, npm version, Docker version, and so on. Nothing fancy. Oh, and if you're running on a ARM machine, so any recent Mac, for example, the official proof server image has a bug. There's a walk-around image from Brick Towers in the README known issues section. Just swap the image, you will be fine. Okay, let's make a quick tour of what's actually in the repo. So it's a turbo monorepo with 3 workspaces. The first workspace is counter contract, easy smart contract, 11 lines of compact source, plus the generated TypeScript types, plus the zero-knowledge proof keys that comes out of the compiler. The second workspace is the counter CLI. It's where the interactive CLI lives, plus the TypeScript API that wraps the Midnight SDK. This is the thing you will actually interact with when you are deploying or debugging from the terminal. And third, you have the front vid React. And well, this is the front end. React vid tank stack router. This is what connects to the browser wallet. At the root, you have the root package JSON with the scripts we will cover in a minute. The turbo JSON, which defines how everything builds. You also have the README file we are following right now, and the Vercel JSON for deployment. The key thing to remember, counter contract produces artifacts that the other 2 consume. So it has to build first. And that's exactly what Turbo is for, which is the next section. Now, let's see the root package JSON in detail. We have there 6 scripts at the root. Let me walk you through them. Compact. This just tells Turbo to go compile all the .compact files across the workspaces. You run this anytime you touch a contract source file. Build is the big one. Turbo builds everything in the right order. Contract first, then the CLI, then the front end. This is what you run when you first clone the repo. Build production is for deployment. It pulls the LFS files first, then builds. Vercel uses this one. Setup standalone is how you boot the local blockchain. You will run this basically every time you work on Undeployed. dApp front end. Spin up the vid dApp server. And lint, which is, it is ESLint, nothing interesting. 6 scripts. That's the whole menu at the top level. So here's Turbo JSON. It's tiny. 4 tasks defined. Take a look. So compact depends on build. Build depends on build and compact. Test and lint depends on compact and build. The piece you need to understand is that little caret prefix next to build. That means before you run this task in my workspace, go run build in all my upstream dependencies first. So practically, when Turbo wants to build counter CLI, it looks at counter CLI dependency, sees counter contract, and says, hold on, I need to build that first. You don't have to think about that order. Turbo figured it out. So let me make that concrete. When you type npm run build at the root, here's what happened. Turbo compiles counter contract first. That's step 1. Step 2, it builds it. 3, it builds counter CLI. And 4, it builds the front end. Done. 1 command, 4 things happen, all in the right order. And here's the really nice bit. Turbo caches. So the first npm run build takes a minute or 2. The second one, if you haven't changed anything, is basically instant. You will notice it. It's great. Okay, so now each workspace has its own scripts too. Let's look at counter contract first. Compact calls the compact compiler. Notice that .30 that pins the toolchain version so everyone compiles the same way. Test just runs vtests. These are fast, simulator-based tests. No Docker, no network. Test compile. Recompiles, then test. Useful when you're actively editing a contract. Build does the TypeScript compilation and copies the compile artifacts into dist. Then you've got lint type check and a little helper to print the compact toolchain version. You probably won't use that too much. Okay, now let's see counter CLI. It has way more scripts because it supports all 4 networks. TUI Undeployed, TUI Preview, TUI Preprod. These are the interactive CLIs for each network. Same code underneath, just pointed at different endpoints. Setup and deploy. That's what setup standalone at the root actually calls. It boots Docker, creates a Genesis wallet, and then holds the process open so Docker doesn't auto clean up. PSO starts just to prove server container. You use this when you are working on preview or preprod. You still need a proof server locally, even though the node and indexer are remote. The test script run integration tests against each network. And these provider testing ones, those are for isolating individual providers when you are debugging. You probably won't need them day one, but they are there. What is the big picture? One TUI script per network. Same code, different config. That's the whole trick. And now we have the front end. We have there 5 scripts, pretty standard. Def is just build. Build is 2 steps. First, it copies the contract keys, then it builds. And copy contract keys, this one's worth a second. It's a shell one-liner that copies the prover keys. verifier keys, and set KIR files from counter contract CRC manage into front with React public midnight counter. Why does this exist? Because the browser cannot read the file system. Vite serves files from public as static assets over HTTP. So the front end has to fetch those zero knowledge keys. This little script bridges the two worlds, file system on one side, HTTP on the other. Then we have preview, which serves the production build locally, and lint, which is ESLint again. Okay, so now let's focus into the .env file. There's two of them. In counter-CLI.env, you've got two things. My preview mnemonic is your 12-word BIP39 phrase for the testnet wallets. This is what the CLI uses to derive keys when you run TUI preview or TUI preprod. If you don't have one yet, the TUI can generate one for you the first time. My undeployed and shielded address is a pre-funded address on the local standalone network. The setup script sends T9 to this address so you can use it for testing right away. And on the front end side, just one variable, bit contract address. This is the contract. The front end will auto join when it loads. You set this after you have deployed a contract through the TUI. Until you set it, the front end can still deploy new contracts. It just won't auto join anything on startup. Alright, this is the file I want you to really understand. Counter CLI src config ts. 4 networks configs, 1 per environment. Undeployed. Everything's local hosts. Node, indexer, proof server. Preview. You are pointing at the public preview RPC and the public preview indexer, but the proof server is still localhost. Preprod. Same shape. Public node, public indexer, local proof server. And mainnet, same shape again. And this is the part I really want you to notice. Look at the proof server column. It's always localhost, every single row. That's not a coincidence. It's a privacy feature. Proof generation happens on your machine, using your private data. And only the zero knowledge proof, which doesn't reveal anything, goes out to the network. Your secrets literally never leave your computer. That's the whole point of Midnight. Okay, running the template on each environment. This is the main thing. Environment 1, undeployed, sometimes called a standalone in the code. This is a fully local blockchain running in Docker. When you run setup standalone, 3 containers come up on your machine. A Midnight node, an indexer, and a proof server. This beautiful thing about Undeployed is that you need no faucet. The Genesis account is hard-coded. The wallet starts pre-funded with T-nights, and because DAS is pre-allocated, you don't even have to do the whole UTXO registration dance. You can just deploy and go. This is where you do all your development. CI runs here. Local demos run here. It's fast. It's offline. And when you're done, you just hit Ctrl-C and the containers clean themselves up. Honestly, if you are just exploring this repo for the first time, spend most of your time here. It is the fastest feedback loop. Now, in the next minute, you're going to see a real demo running the counter smart contract under the first scenario. Okay, let's start with the second environment, preview, the public testnet. Instead of a local node, preview uses the public preview endpoints. For the wallet, you cannot use the Genesis seed anymore because it's a public chain. You use a real BIP39 mnemonic, the one in your .env file. The TUI can generate one for you the first time if you don't have one yet. Then you need T9, which you get from the faucet. The URL is in the README file. And then here's the gotcha. You need Dust to pay fees. T9 by itself doesn't cover transaction fees. You have to register your Night's UTXOs for Dust generation on chain, and then wait for Dust to generate. The TUI handles all of that for you, but it could take a minute for the first time. I'm telling you now because this is the number one thing new Midnight developers get stuck on. T9 comes from the faucet. Dust comes from the registering UTXO. Two different tokens. Remember that and you will save yourself an hour of headaches. Now, you will see another demo, real demo, running the counter smart contract under the second scenario. Okay, it's time for environment 3, Preprod. This is the production mirror. Preprod is set up to match Mainnet as closely as possible. Same parameters, same ledger version. You use it when you're about to ship something and you want one last round of QA against a Mainnet equivalent network. Setup is identical to preview. Local proof server, mnemonics wallet, task flow, all the same. The only thing that's different is the URLs. Commands are npm run ps-all for the proof server and npm run TUI preprod for the CLI. Same pattern as preview. And environment 4, mainnet, the real thing. Same code, same script. The only difference is the URLs in config.ts and the fact that now you're playing with real night and real dust, real money, real consequences. There's no faucet. You acquire night through an exchange or a bridge. Every transaction costs real dust. Every deployment is permanent on a public chain where real users can see it. The template has a mainnet config entry in config.ts, but there's no default to mainnet script. You would add that yourself, based on the existing ones. Before you deploy anything to mainnet, test it on preview. Test it on preprod. Get your contract audited. Back up your wallet keys. Really, back them up. Not, I will remember that later. Back them up. And triple check that contract address indeed contract address. Mainnet is the one environment where mistakes actually cost a lot. So here's the summary of when to use each one. Undeployed. Genesis seed for development. This is where you live day to day. Preview. Mnemonic wallet. Faucet funded. For public testing, QA, and showing demos to other people. Preprod. Same setup as preview. For final pre-release validation. And finally, mainnet. This one you build yourself. And here you have real nights for real releases. One repo, 4 environments, and the code never changes, just the config. That's the whole abstraction. Whatever you build, it's going to work on any network. So you can develop on Undeployed, test on Preview, and ship to Mainnet without rewriting anything. One more thing about environments, the front end. The front end doesn't care which network you're on. It just follows whatever the connected browser wallet is configured for. You run npm run dev frontend from the repo root, and that's it. Dev server comes up on localhost. This is the part I want you to really get. The front end reads the network from the wallet extension, not from the environment variables. So if your Lace wallet is set to preview, the dApp talks to preview. Switch Lace to undeployed, the dApps talks to your undeployed environment. Nothing in the code changes. The only .env variable the front end actually needs is vid contract address. This tells which contract to join. And that's it, which brings us to the wallets. Okay, wallets, Lace and 1am. So you have two options. Both are browser extensions. Both implement the same dApp connector API, and the template supports both. Lace is the IOG reference wallet. You install it from the Chrome Web Store, same as any other extension. Supports all 4 Midnight networks. If you have touched anything in the Cardano ecosystem, the UI will feel familiar immediately. 1am is an alternative, a different Midnight wallet with its own take on the UX. You install it from the project side. The template treats them the same. There's no special code for Lace versus 1am. The front end just looks at window Midnight, sees whatever wallet are there, and lists them. So you can have both installed at the same time and pick whichever one you want for a given test. Okay, let me walk you through Lace first. Step 1. Install from the Chrome Web Store. Links in the README. Step 2. Open Lace and either create a new wallet or restore from an existing mnemonic. A good tip here, if you use the same mnemonic you put in my preview mnemonic, then your Lace wallet and your CLI wallet are the same wallet, same address, same funds. That's nice when you're switching between the terminal and the browser. Step 3. Pick the network in Lace settings. This is important. If you're gonna test against preview, make sure Lace is on preview. If you are on undeployed, Lace has to be on undeployed. Otherwise, nothing talks to anything. Step 4. Fund the wallet. Faucet for testnet. Nothing to do for undeployed because Genesis is already funded. Under the hood, when Lace loads, it injects a property at window Midnight Lace. The front end picks that up, calls initial API connect, and you get the approval pop-up. That's the whole dance. Okay, now 1am, same shape. Install the extension, open it, create or restore a wallet, pick the network, fund it if you are on testnet. The key thing is that 1am implements the same dApp connector API Lace does, same interface, same methods. The front end doesn't have to know it's a different wallet. It just sees another entry in window Midnight and lists it in the picker. Here's a tip I actually recommend. Install both wallets. Keep them both around. It lets you test your dApp with multiple wallet implementation, catch any wallet-specific bugs, and just generally be a better citizen on the ecosystem. Only one wallet is active per tab at a time, but you can switch. Now, I'm gonna show you a real demo of how it looks this front end running the counter smart contract using the Lace wallet. As we mentioned previously, we can either use the Lace wallet or the 1am wallet. Alright, let me recap what we have covered so far. Requirements. We need Node, Docker, Git LFS, Compact, a browser wallet, and faucet access if you are on testnet. Pretty standard stuff, nothing exotic. Build system. One npm run build, and Turbo handles the whole dependency order for you. Contract first, CLI and front end after. And it cache, so the second build is basically free. 4 environments: Undeployed for development, Preview for public testing, Preprod for production rehearsal, and Mainnet for the real deal. One repo, one command per network. 2 wallets, Lace and 1AM. Both work. Install whichever you prefer, or both. And the front end. The wallet decides the network, not a config file. Only thing the frontend actually needs from .env is the correct address. That's it. Now you know how to run this repo in any environment with any wallet. Here's what I actually want you to do after this video. Clone the repo, pull the LFS files, install dependencies, and build. Then run setup standalone in one terminal and then front end in another. That's it. You will have a local midnight dApp running in maybe 15 minutes. Then install Lace or 1AM, connect, and deploy your first contract. If this was helpful, please leave a comment. Tell me which environment and which wallet you end up using. I will read you. Thanks for watching. See you in the next video.